Welcome to Coding Koans, where together we are going to explore the secrets of software development, get better jobs, and change the world. My name's Ian Carroll, and it is Christmas season now, officially. I'm going to declare it because it's after Halloween. I know, Thanksgiving, for those of you who like Thanksgiving, great, but I'm wearing this sweater because Captain America. We're going to explore some JavaScript code today with my guest, MeLissa Luna. MeLissa is a comedian, podcast host, and 50% of the musical comedy duo Erin and MeLissa. Together they host a show on Outpost 13 called Group Text with Erin and MeLissa about friendship and technology, which you can catch Tuesday nights. MeLissa, welcome to the show. Go ahead and turn on your video.
Oh my goodness, Ian, you did so good because 50% of that you had to create by yourself. So honestly, that was a better bio than what I provided to you.
Yeah, well, improv. I could see where you were going with it, so I just patted it a little bit, made it a little, zhuzh it up a bit. I don't even know what zhuzhing up means, but I've heard people say that before.
Yeah, it's a feeling. It's more a feeling. It's like, I dare say it's almost onomatopoeia. It's like a zhuzh. If you had to just like zhuzh, it's like almost a sound your sweater would make if you had to like fluff it. Zhuzh.
Yeah, just zhuzh it up a little.
Yeah, there you go. You got it. It's in your heart. Zhuzh, yeah. It's in you.
MeLissa, I'm so glad that you're here. From what I understand, you work for a technology company, but you're not a software developer. Is that right?
You know what? I truly was like, Ian, I'm the worst guest, and I run a technology podcast, and I do work for a software company that makes intranets, and I have to talk to people all day about like
making
servers,
internet.
Yeah, web farms. Yeah, I make intranet. I don't make it. Much more brilliant people do, but lots of people ask me questions, and I'm like, why would you even ask me? What human should know the answers to this? But they do, and I find out the answers. And so I actually do a lot of things with technology, and I didn't even realize it. That's how separated it is in my head.
Yeah, I have a feeling that you're not alone in this, that there are a lot of people who say, oh no, I don't understand that, but in truth, you're doing it all the time anyway. It's sort of like, I don't know, the Karate Kid.
Yeah.
It's like here I'm just waxing on and waxing off.
Here's the truth. I have preserved like a sizable amount of information from MySpace days, and I make a lot of references to that in my daily work life, from having to learn basic like coding and HTML. It felt like a cool challenge to be able to like figure out how to get glittery GIFs on your page. And so if you were like one of the strong ones, you could survive. And so there's some of that stuff that I've still borrowed and have carried ever since. And now it's a thing I talk about a lot with people that I work with, because some people, if you can reference like skill sets that they used on MySpace, it kind of gives them a gauge about what to expect with software and how savvy they'll have to be. And wow. So MySpace is the gift that keeps on giving. Is this podcast about MySpace? That's what I was going to ask.
In a sense, yes. Many of my guests, and me included, have fussed with the CSS on MySpace pages to make it look just our own special flavor of lame.
I love it.
So, yeah, I mean, of course. Another big one I hear a lot is Neopets.
Okay, so I think I missed whatever happened with the Neopet. Is it related to is it in the same family as Tamagotchi?
I think so. I didn't actually do it myself, so
I thought Neopets was a book, but I think that's a Transformer thing where they go from being people to animals. But I thought Neopets was a book, but I don't think it is.
On the tip of my tongue, there's something deep in the recesses of my brain that's trying to correct you and is failing to actually do it.
Yeah. They got stored in the same folder in my indexing system in my brain. Whatever that is, Animazords, Animalzords.
Animorphs.
Animorphs. Oh my gosh, we did it.
Yeah, we did it.
It's an Elasticsearch up here.
There we are. Yeah, it's you know, the algorithm is a little slow, a little inefficient. Takes a little time to look it up, but it eventually gets it.
Honestly, we haven't searched those tags in a while, so they're showing up pretty low.
Hmm.
The search results.
So you do a show on Outpost 13 as well.
I do.
Um,
So, oh, go ahead.
no, go for it.
So, my best friend and I, she's the other 50%. So, Erin McGowan and I have had a podcast for a while called Group Text with Erin and MeLissa. And that was born out of we have been friends for so long and people have met us as friends. And so we've kind of become like a Mary Kate Ashley to a lot of folks in our lives. And so it came out of like this frustration where people kind of made us one entity. And so we were talking a lot about like texting rules, how communication rules have changed with the advent of technology. And then it just kind of morphed into a way for us to talk to really interesting people about technology and how they're using it. Then it kind of took a nap, and then we were in a apocalypse. And so starting this year. And so in the middle of that, Erin and I were like, well, why don't we resurrect this and see how, technology technology is already running at leaps and bounds, but especially when everybody's forced to stay at home
Hmm.
in a major way, and how that is adapting communication rules and therefore, as a result, friendship and relationships in general. So that's what we talk about our group text.
That's amazing stuff. That is something that I think about a lot as a software engineer as well. I think it's really important, and part of the reason why I have this show is to empower more people to take control of the technology that they're using, or at least to understand what's going on under the hood. You don't have to be a car mechanic, but probably a good idea if you know kind of what's going on under that hood. And if you were to open up that hood, you wouldn't be completely terrified. You'd only be 80% terrified.
Well, the truth is, we start our podcast by always asking our guests, between a scale of 1 and Steve Wozniak, how do you feel? Where would you rate yourself as far as technology? And most people will rate themselves low
Oh, yeah.
because they say, well, I don't know how to code, so I'm like a 5. And the truth is, like, some people are like 10s at TikTok, or they're 10s at navigating, like, what's the best way to get a deal on, like plane tickets
Right.
on Google. So you're a 10 at something, but people do consider coding to be a 10. But like you said, the more I've learned at work, the more I'm like, oh, okay, I think I'm getting a general sense. It has been helpful to have some base knowledge of
Yeah.
coding in general.
And let me also say to that every year that I progress in my job as a software engineer, the lower that number goes. I just learn more and more what I don't know. And there's a lot that I don't know.
Yeah.
And part of the reason, like one part of it is just the vast multi-dimensional ocean of technologies
Yeah.
and ways that you can use the technologies, is one thing. But then there's like the other thing is like sometimes people just write really crappy code. And there's absolutely no reason for it to be as complicated as it is, except somebody wanted to be clever. So they wrote it
Or
this
it was
way.
me. I wrote it, and it was pieced together from Wikipedia pages and screenshots. And so I built the app.
I almost think that's better, to be honest. I've seen people get too clever by half. It's like, it does not need to do this. You just need to do that. But that takes time to learn how to do it like that. It governs our lives. It really
Yeah.
does. Like, there's
Do you-
no part of reality that we touch that isn't also affected by software.
Well, and now if you launch any business, the first thing people look for is like, where's the website? Where's the app that goes along with it? And like an app is a whole different thing. Like at work, we have all of our web builders and developers there, but we have other people who are working exclusively on the app.
Yes.
And so like, if you're a business that's launching, like that's a huge investment in like I have kind of this belief that maybe in primary school you should have to do basics in classes like like hair care, like a little bit of most of the careers, because like I can't curl my hair. That's why I look like Mowgli today. I don't know how to do that. It's like you should have a little bit of like car mechanic skills. You should have a little bit of like tax management. And it feels like, software, there's always going to be the experts, but it feels like everybody should have a little bit, like know a little bit about everything and everything about a little bit. And so it feels, I'm with you. How much do we do that hasn't had some person coding and developing it for us to interact with it? Like for you to
Yeah.
order your Starbucks.
Well, actually, that raises a really, like, it only occurred to me a couple of days ago. And I was walking around and I realized that every single thing that I interact with that has some software element, which is just about everything, someone actually wrote that.
Yeah.
One day, well, maybe a couple of years ago, maybe more than that, maybe last week. Someone actually wrote that.
Yeah.
Someone willed that into existence by being there. It isn't like some, this is magical technology that just surrounds us. On the other side is another human being or a team of people. And that's frightening, especially when I work with, like, when I was working at the Barnes & Noble, I, worked with their point of sale system. And my God, the user interface on that thing, like, I was like, every day I would work with it. And then it occurred to me, like, whoever developed this hates me.
Yeah.
They hate me. They
Yeah. Well, and also, if you want to just dig further into your existential crisis, you're like, everything that seems simple, there's likely a team of something behind it that made it seem that simple. And so it's like, how many mental breakdowns can we have in the course of this one episode? I dare say we could have a few. So
quite
yes,
a few.
yeah. That's a great revelation.
Yeah. So
And dude, what can I ask? Am I allowed to ask you, like, what kind of software do you develop? What do you do? What are you doing every day?
right now I'm working on Webrtc, which is JavaScript based.
Okay.
And Webrtc is streaming real-time communications. That's what the RTC stands for, real-time communications. It was developed by Google. I think Google might have developed it in a way where it is so hard to use that it would slow everyone else down on trying to use it.
Yeah.
Because they didn't want the competition.
Makes sense.
Yeah, I'm still trying to figure out how to write that cleanly. And it's rough, but it's fascinating because I use it, and everybody around me uses it, and it was relevant and necessary before the pandemic, but now that everyone has been forced onto it, it's even more relevant. Even Zoom that we're using right now, this technology uses their own Frankenstein version of Webrtc. It's not actually Webrtc anymore. Whatever it is, it's more machine now than man, twisted and evil. But it's there.
Real Jurassic Park stuff going on. It's like, before we asked, could we do it? We should have asked, should we do it? And here we are. We're on Zoom, and I don't know what deals we've made.
I mean, we're staying healthy, and we're still having shows. And
that's true.
We're teaching people. It all depends on how you use it.
Okay.
But yeah, still. Well, on that cheery note, you want to try and pair program a little bit?
Yeah.
Okay, cool. So here is how pair programming works. Number one is there's no such thing as someone who's an expert and someone who's not. Everyone who's there is part of a team, and we're going to make something together. The pattern I'm going to use for how we're going to pair programming just means two people with one computer. Two people, one computer. And so the two of us are going to program together on a single computer, and we're going to use the driver navigator paradigm. So what I'm going to be doing is I'm going to be the driver. So I'm going to be the one with their hands on the keyboard, and you're going to be the navigator, the one who is giving various level instructions to the driver on what to do. We're going to talk as we do it and discover how to make things work. But that's pretty much how this is going to go.
So I'm the Waze app, is what you're telling me.
Yeah, that's exactly what you are.
Okay.
Yeah. So with that being said, let me go ahead and pull up the code that we're going to work on today. Is a little tiny color resistor thing. Let me share my screen. And here.
Well, I'm over the moon already.
Okay.
Color resistor.
Color resistor.
Are you going to tell me
duo.
what that is?
Yeah, so what we're going to be writing is a little tiny program that's going to help us when we're working on a Raspberry Pi.
Now, this pi has no E, so is that a code word for something else?
Mm-hmm. It's this thing right here.
What is that?
This is an open source computer. Open source meaning this is open source hardware. You might have heard of open source software before, right?
Mm-hmm.
Okay. So open source software is free, as in free speech, rather than free as in free beer, to quote somebody famous. Someone
Honestly,
out there
that's
might know it.
helpful.
Yeah. And so this is open source, as in the plans for this are free and available for anyone to duplicate. But this right here is a computer, a whole thing.
Okay.
This is a $35 computer.
And so then from there, you would build from the ground up, everything turning on, everything, how you log in, all that stuff.
Yeah, so here is, by the way, I'm holding this with my bare hands. And those of you who are PC builders out there are going, oh, no, don't do that. It doesn't matter. It's a $35 computer. And I've never once destroyed one of these. And if I do, I'll just order another one. It's no big deal. So you can see right here, here are your USB ports. Here's an Ethernet port. Power can be supplied via this, or this, I think. Actually, I think this is for audio. This is an audio jack. Here is the processor, the CPU.
Okay.
And you can use this little computer just like you would any other. Just hook it up with a with a monitor, and you can use it just like a Linux computer. I think you can even install Windows 10 on it, because Windows was realizing that if everyone had these free computers, they'd stop using Windows. So they started offering it for free, so that they could keep their market share.
So that's in your Apple laptop, and essentially like, or that is not.
Well, something like this is in your
Okay.
Apple laptop.
But a trademark version that you can't just walk around on the streets with.
Right. This is an open source one.
Okay.
Which means that if I wanted to build this on my own and just source it from parts and use their plan to build it, nobody would come to sue me.
Okay.
Which also means that I can use this little cheap thing here to build little IoT devices. So let's say that you have a little smart device that connects to the internet, and you can turn it on and off. Let's say you have a coffee pot, and you want it so that when you go to a certain website, it starts making coffee. You can do that with
my
this.
language. Okay.
Right.
Okay.
And these right here are the pins that allow you to connect it to other devices, or to create your own electronics that this little computer would control.
Okay,
So
I'm
this is a
loving
Raspberry Pi, and then we're going to be working on something that uses that tells us the color of these little resistors. Not sure if you
What
can
are the
see that.
resistors? So this is just like,
Pure
we're going to make it
electronics.
light up essentially. Yeah?
Yeah. You could use this to turn a light on or off. You could use it for much more complicated things than that. The Tesla that you may one day drive may include something like this combined with something like this. In fact, it has to. They might have their own version of this, but yes. And then these are the actual resistors, which allow for the electricity to go through. And I'm not sure if you can see it. It's going to be hard. Let me see if I can get out of the way of the camera. No, it's not working. Maybe now? No.
I see the little pegs in the middle.
Yeah, the pegs in the middle are the things that stop the electricity from going through entirely,
Okay.
which allows for the control of that. And you'll see that there's little strips on those, right? Yeah. So those strips are because of the fact that these are so small, it's really hard for you to write numbers on them. What they do is they put these little color-coded bars on them to tell you what value this is. Like right now I can't really tell. I think this is, I'm seeing a red one, a blue one, a black one, a gold one. That means something.
Okay. I believe you.
So we're going to build something using that. And we're going to use this thing called color resistor duo when we do this. So if you want to build something with the Raspberry Pi, you'll probably use resistors. For this exercise, you'll need to know two things about them. One, each resistor has a resistance value. And the resistors are small. So small that you can't print the numbers on them. So instead, or you can, but what's the point if you need a magnifying glass to see them? To get around this problem, manufacturers print color-coded bands on the resistors to denote their resistance value. Each band has a position and a numeric value. For example, if they printed a brown band, which means 1, followed by a green band, value 5, it would translate to the number 15. So in this case, we're going to create a helpful program so that you don't have to remember these values of the bands. The program will take color names as input and output a 2-digit number, even if the input is more than 2 colors. So colors are mapped to the numbers 0 through 9 in this sequence. Black is 0, brown is 1, red is 2, orange is 3, yellow is 4, green is 5, blue 6, violet 7, gray 8, white 9.
Okay, so then for the example above, this part says brown green should be 1 5.
Right.
Brown green violet will also be 1 5. So is there a point to having, like, are you only ever limited to 2 color values?
No, we could change it so that we could actually do this and just map all these colors to whatever set of numbers we wanted to. But for this little function that we're going to write, this little helpful program, it's only going to care about those first 2 numbers. It's going to ignore anything after that.
Okay.
All right. So in order to do that, right now I'm using a text editor called VS Code. And this, and I also have a little cheat that is absolutely what we're going to use. I'll get to that in a second. So first thing we do is we use this terminal down here, which is the traditional way in which hackers use the internet. Not really true, kind of true, a little bit true, not at all true. So we're going to npm install real quick, see how that goes. This is going to install any dependencies that we need.
Okay.
This is also taking more time than I expect it to. Why is it taking so long? Why? Why? And then after that, we're going to run this test. And we're going to do something called test-driven development today. So that's going to help us to focus on just writing the barest minimum of what we need, and also give us the confidence to be able to run those tests over and over again so that we don't break anything as we improve the quality of our code.
Okay.
So resistor color duo, we have a spec here. And here we are. So we're going to import something called decoded value from the JavaScript file that is right here. And let's see, here it is, decoded value. And it's exporting this. Here are some comments above here, which I'm immediately going to delete because we no longer need them. I don't care about those. And right now, all it does is it runs whatever is inside this block, which is going to throw an error that says remove this statement and implement this function. So let's see what happens when we npm test that. It should fail, and it should tell us remove this statement and implement this function.
And where did you get this code from? Is this one of the, where did this come from?
This came from a website called exorcism.io.
Okay.
And that is a website that is designed to help people understand coding languages with mentors or on your own using the tools of test-driven development.
Mm-hmm.
So yeah, we failed it. Great. Error, remove the statement. Wonderful. So, yeah. So it says brown and black. So let's see. We want this to equal 10. So we want to put in this, and what comes out the other end should be that.
Okay.
So first of all, decoded value, you might notice, doesn't take anything. Anything that it would take would go in here. So I guess right now we should name this something so that it can take a value and give something back. This is called a parameter, by the way, when we do this, or an argument, sometimes called. So this function is going to need an argument. Now at this point, this is where creativity and human ingenuity come in. We can name this whatever we like. We could name it something like that, if we want to.
Okay.
We could also name it something like 8472, for example. Mm-hmm. What's wrong with naming it argument 8472?
This is going to be a test that I fail. I don't know.
Well,
is it going to add that number in somehow?
What, like, why is it like let's start with why 8472?
Oh, yeah.
All right, so let's say that, like, okay, this is actually English here. So now we have something called argument. That's extremely generic. I don't need to know that it's an argument in order to see that that's an argument. So what kind of argument are we actually passing it in? And let's look at what this thing is. What's this? This is what we actually pass in. What does that represent?
Those represent resistors, yeah?
Resistors.
Passes. Colors?
Resistor colors, right?
Yeah. They're values, yeah.
Okay, they are values. Yes, that's true. This is, to use computer science, this is an array, and that array has two elements in it, and those elements are strings, and each string is the word brown or black, okay? Mm-hmm. But that is not all. I mean, we could say, you know, color array or something like that, but I hate that. And the reason I hate that is because we should be able to tell it's an array by how it's used. So what does that actually represent? Colors, you said? Mm-hmm. Is it colors? Is it a color? Do we want to call a color duo?
Yeah.
So we're going to pass it a color duo.
Okay.
And then from that, it's now going to throw this error. So we've changed the code, save it, run the test again. Still is going to fail just the way it did before. How do we make this pass? Well, obviously we need to get rid of this. Remove this statement. Implement this function. Okay, cool. Let's say that we're going to return something. What's the dumbest possible thing you can think of that will make this test pass? So we're going to take this right here, decoded value brown black. And we want, when we call decoded value brown black, it's going to equal this.
10. Yeah, 1, 0.
1, 0. So what's the dumbest thing we could possibly do to make this pass, forgetting about everything else?
Just name it 1, 0. Is that all? Is that all we need?
Return 10.
Man, I'm a coder, and it's just like really hard to identify this new version of my personality, you know?
Yeah, there you go. See?
My brain's not so strong.
If you have the right process, the right kinds of tools to use, it's suddenly a lot easier. Here we are. We've passed that test. Great.
Here's the truth. You're probably the most important part of this process. All the others is just like, really? I'm not contributing much to the process.
No, you actually are. You're thinking about this. So let's go back and look at this for a second here, and let's sort of return some things. So like 10, good, we got that in there. We got this name color duo, right? We're not doing anything with color duo. It's just sitting there. Like if we were to like, oh wait, there is something we can do. And let me show you this. A little while ago, someone else was here and we were working on resistor color itself. And we have this thing called color code that the resistor color does. It takes a color and then it returns whatever the number of this color set is.
Okay. So like the 1, the 0, the 8, all that stuff.
Yeah, so let's see. There's a spec for that, resistor color, and that includes how to import this. So I can copy that and put that into the resistor color duo and cheat by not having to reinvent the wheel.
Okay. So it's going to apply all those values that you have already established.
Right, and also, by the way, this is also test-driven as well, which color code black, 0. Color code white, 9, right?
Mm-hmm.
So let's see what happens when we do that. We do not need colors. We just need color code. Am I going to be able to do this? I think I need to, there's a little path issue going on here, I think. Let's see what happens. Let's see if it breaks. I kind of bring this in. So what you're seeing up here, this dot and these dot and this slash is trying, what it's doing is it's creating a path and it's trying to figure out where that path is. Right now it's saying, see, it's already failing, right? And it's saying what? Test failed. See above for more details. Let me read this. Why is it telling me no to that? Well, what happens if I just don't? What if I do it like this? It shouldn't be able to... Oh, wait. Hold on. So it needs to go up 1. So the problem is that here's resistor color 0, and here's resistor color. In order to get there, I need to go up 1, outside of this folder, and then down 1 into this folder. So that means that it's not just this, it's that.
So you're having to like manually write out the hierarchy that they're pulling the code from.
Yeah, I'm trying to point it at the code that it needs to remember about.
Mm-hmm.
And let's see if it knows what that is or not. This, unfortunately, sometimes the error messages are not very good. Oh, good! It knows what that is. Great. Okay, that means that we can now use that. So now if we have color code, we can say this. I think somebody might have just followed our channel. Thank you.
Oh, that's exciting.
Yeah. So we're going to need going to declare a variable here, which is going to be, let's do the tens place. We can name this variable whatever we like. If we don't like tens place, we can do something else. Color, and then we're going to call color code the way that we saw it inside of this spec, which goes color code. Okay, so we're going to need to grab the black from here. In order to do that, we're going to need to reference it from that array because we can't just ask for black because it isn't in there. So we're going to need to do... So, all right, where's the tens place in this resistor? Which of these is the tens place? Is it the black number or the brown number?
It's the brown, yeah?
Is it brown?
Am I remembering it in reverse order?
You might be.
Was it like 1 tens?
Because look, black
10.
is 0 and brown is 1.
Okay.
So that means that, as weird as it seems, the tens place is over here, weirdly flipped. I find that stupid. Now, there's a reason why they've done it that way. And either the resistors themselves, when you read them, you actually read them this way, or this needs to be plugged into some sort of legacy code that's just stupidly written. And we need to interface with it the way it likes to be talked to, even though it's a stupid way for something to be talked to.
Okay, so black is our tens place then.
Right, so that's the tens place. So, all right. In order to grab this value, we need the key, which you already said. You said key and a value, right? The key, which is not being shown, is going to be the index number in this array. So arrays are 0 indexed, which means that the first number is always 0. So this, we can get this by saying color duo 0, and this is color duo 1.
Okay.
Right. So should be able to do that, right? Does that look right?
Well, we forgot our 0, right?
We're not caring about the 0 just yet.
Oh, okay. Oh, because we're just doing the tens place right now.
Right now, yeah.
Okay.
So this makes no difference. We're going to do, oh man, let's not do the tens place. Well, we'll come back to that. What's the other thing that we need? The ones place? Makes sense to have a tens and a ones place, right?
Correct. I think so.
All right, and color code for our ones place, if color duo 1 is our tens place.
So then 0 is our other one.
You are a software developer. Welcome to the ranks.
Oh my gosh. Just
Okay.
didn't think this day would happen, and it barely has.
So we can do this. This should still pass. And this is getting closer to being accurate, right? 10 plus the ones place, right? Pass, please pass, please pass, please pass, please pass.
Is it literally doing math of like 1, 0 plus 0, so it will be...
It should be that, except that something went wrong. What went wrong? It received 11? Wait, just one stinking minute. Oh! I read this wrong. I read this so wrong. Brown is the tens place. Black is the ones place.
Is the ones place? Okay.
I was so stupid. Oh my gosh.
Oh.
Wow. So that means that if we did this is why you need tests, by the way. Because your eyes fool you so much. You know, I swear, you know, coding is a lot simpler if you just read what's in front of your face.
I'm going to argue because it looks pretty hard. You're making it sound nice.
Okay, here's another secret of software development. If it's hard, it's because you made it hard. If it's nice, it's because you're making it nice.
You know what? I'll accept that.
So now it's passing. 10 plus the ones place, which is now referencing the actual ones place.
Okay.
Good. All right. Now how do we get the tens place? Because if we were to do that, if we did tens place, for example, here, instead of doing that, this isn't going to work, right? This is going to give us the number 1, right? It's going to say, because 0 plus 1 is 1. So how do we get that tens place to be right?
You know, I haven't the faintest idea.
All
Tens place? Because we want it to equal 1? Is that what you're saying?
No, we don't. We want it to equal 10. Right now it's adding the two numbers together, and we want those two numbers to go 1, 0, right? So how do we get that?
Can we flip them? Can we make ones place first and then tens place?
I think ones place plus tens place is still going to be, now
Just
instead of
equal
1
one.
plus 0, it'll be 0 plus 1.
Okay.
So
And we need it to literally add up to 10.
that's right. So how do we get it to add up to 10 where the tens place is separate from the ones place?
Is this where we add in a third color?
We're not going to add in a third color, I don't think, because if we look at the rest of these, oh yeah, there's one where it does, but it still is going to be 5-1. It's going to ignore additional colors.
Then I don't know.
Well, let's think about base numbers here for a second.
Okay.
So there are only 9 numbers, right? Actually, there are 10 numbers.
Yeah,
0,
if you're counting 0. Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. So we can only count to 10. So how do we ever say that anything is more than 9 of something? Otherwise, we could say there are 9 stars in the sky, and there are 9 fingers, and Joe Biden won all 9 states, or whatever else. How do we get past 9? What do we do?
You start adding in multiples of 9.
So,
like additional sets of 9s is my
right. You put another. You make it 0 again, and you put another one on the top. Right.
Does this mean we have to do like brown, black, brown, black, brown, black on top of each other? Is that what you mean?
No, not exactly. So the problem is that we're trying to add this. Although this says tens place, this is not correct. This is a tens digit. This is a ones digit, right?
So now that equals 11, is that why it fails?
Except that the tens digit is lying right now, because in fact, in fact, the tens digit right now, this is not a real tens digit. It's actually still in the ones. So how do we make it 10? So color duo 0 is going to be a 1, but it's not 1. It actually needs to be 10. And 10 plus 0 is what we want, right? So how do we make this digit 1 through 9 10? There's a couple of ways I think we can do it.
Okay.
So let's forget about this for a second. Let's call it what it's actually showing us, 1. And this is actually 0. So 1 plus 0, right? This needs to be 10 plus 0, right? Well, 1 times 10 should be 10, right?
Okay.
And if we had 2 times 10 is 20, right? 3 times 10? 30. That should probably work.
We're trying to get all the way to what number?
As many as we want, all the way. That's as high as we can go. We're never going to have a value that isn't 0 through 9 because our color code doesn't allow for that.
Okay.
Right? So color code, and then we use 0, and then we multiply it by 10. Jonathan Blocker just followed the channel. Thank you, Jonathan Blocker.
So 0 times 10 is still going to be 0, and I thought 10 is an increment larger than 9.
Hold on. let
Okay,
me let,
you
let me
finish your
let me
black
just
magic.
It ain't black magic. It is. If we do it right, it is simple. So, all right. Color code 0. This whole thing right here is just nothing more than a single digit. And we're going to make it the tens digit by multiplying it by 10.
Okay. But can you multiply things by 10? I thought they could only go up to 9.
You're right. So in order to get past 9, we need to multiply it by 10.
Okay.
Or we no, I think times 10 is going to be the way to go. There could be some other ways to do that. I'm not sure if anybody else in the chat has another way. But by doing this number right here is going to be 0. 0 times 10 is 0. That's what we would expect it to be. That's not going to destroy anything because no matter what number this is, 0 plus that number is going to be that number, right? Cool. All right. If it's 1, it's going to be 10. It's 2, it's going to be 20. 3, 30, right? So that should work. 10's digit plus 1's digit. There's another way we could go about it, but I'm thinking that this is probably a decent way. Let's see. Does this work?
Because the goal is still to make it equal 15, is that right?
Right now we're still just trying to make it 10 again. We're still trying to make it 10.
Okay.
Failed. Why is it failing? Negative 11. That's weird. Why? Oh, wait, no. That's so weird. Why is it that? We're going to use something called console log to just print something out and see what this says.
Okay.
These tests take forever. I hate how long these tests take. Something like so. I did this. Why? Console log negative 10. Negative 10. Why is it negative 10?
Somebody in the chat says, looks right, middle band is times 10.
Yeah.
Is that for you?
Yeah. Had to do an image search for resistor colors. Yeah. We're just so you know, Chad Ridden, we're working on a little program that's going to turn color values into numbers. So
yeah, Chad Ridden's my friend. He is the head of a lot of amazing stand-up in Nashville, Tennessee, and he is. I got to meet him when I was just a baby stand-up, and he's been a part of my life ever since. So I'm glad to have Chad joining us today.
Well, that's great. So I'm still confused as to why this is turning into a negative. It should not be.
Erzbane is asking, what is a color code array? Color code map.
This is a terrible way to do this, but this should solve my problem. Okay, what's in the color code array? Yeah, the color code array that it's referencing, just so you know, is this. It's these colors. It's nothing more than an array, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These should not end up being negative, and it's just the index of it. Returns whatever the index of that color is. So I don't understand where this negative is coming from. And now it's claiming that it's receiving 11. And how?
I'm truly amazed by how many people are in this chat who understand what's happening right now.
This doesn't
This
make any
is amazing.
times. Oh, I know why.
Why does that say -1?
Oh, wait.
Those both say negative. They say times minus 10.
I'm just trying something because
Okay.
it's coming back as negative, and I don't want it to be.
Oh, you did that. Okay, got it, got it.
So if I do this, I wonder if that will do it. Can I get away with that? This is ridiculously stupid to write it this way. I hate this. I hate this so much. But let's see if it'll actually work. These are just 10 digits, 10-digit numbers. They're just base 10, Chad written. So there's no color code 0 should not be a string. Wait, what? No, it should be a number. It should be returning a number. And these are returning numbers too in the other resistor color before we got to resistor color duo. So I don't know why that's happening. And it's still failing, and now it's saying -10. This is so weird. All right, let's do that. Because times -1 is just going to flip the, make it negative for whatever it is. But now it's still saying it's -11? But why? Why is it saying that? How is it? This is boggling my mind right now, MeLissa.
I'm telling you, it's me. We're connected via one Zoom chat. It could be like sucking some of your IQ out.
There's no way. There's no IQ involved with this. Being a software developer is not smartness. It's actually extreme dumbness.
I might agree to disagree based on this right now, because you've asked me some what sounds to be pretty standard questions. I've gotten none of them right. Oh, these are all saying negative.
Yeah, why? Oh, okay. But the array has number indexes and string values. Yeah, you're right. The array has number indexes and string values, but if you notice the resistor color, okay, in this resistor colors thing, it's returning the index of that color. So it's going to return the key, which is going to be an integer. And so this should be 0. This should be 1. So if it finds the color brown, it will return the index of that color, which is going to be 1. So I'm wondering why it is that's not happening. So let's just take away the 1 and the 10 for now, because for whatever reason, that's causing some trouble. Man.
We're doing some cardio now.
I want to get this right. Because
well, here's a question. What will happen when we do get it right? What will that do?
It'll pass the test so that we can move on to the next test. That's what I'm hoping for. I'm just trying to figure out what it is that I'm doing that's wrong. Okay, cool. Let's try that. Let's just negate this. I don't know why it's being a butthead about that. That doesn't make any sense why it would return negative. Okay, now it's getting something closer to correct. Now we multiply it by 10. Let's see how that goes. this makes no sense why it would do that. And the other tests prove that it works. And now the ones digit is still coming up as oh, I am so dumb. Here's my problem. I'm just giving it an array that has 0 in it, and that's it. And then multiplying it by 10.
That's
I'm
what
not
I was
actually
gonna
using
say.
color duo at all. I need this. Color duo 0. Color duo 1. That's my problem. Oh my god. That's it. That must be it. Let's see if that works.
Is this what Airsbane was saying? I think he or she, they had something like color code, then the box, and then 0. So maybe
Yeah.
you're okay.
Yeah, and had I been reading Airsbane's message, then I
It's hard to
would...
code and read.
Coding is mostly about reading. So the lookup
but we
could be
know the
failed.
game.
Yeah, because -1 means not found. Oh, okay. Yeah, okay. Now it's making sense.
We passed!
And now it's working. Because the fact that we're actually using this, because I had taken the word color code and sort of decided that that meant color duo as well, and that's just not true. It needs to be given that. 10's digit plus 1's digit. 10's digit is using color code color duo 0, color code color duo. Let's just call this duo, because obviously the way in which I was saying that was just blowing my mind, and I didn't understand what I was doing wrong. Now it's time for a little refactoring, which is what we're doing right now. Refactoring just means writing the same thing again, but in a slightly nicer way. And let me check. I think from here, the other tests will start passing. If I uncomment this test and I run it, it's probably going to pass. I think it's going to pass. It's going to pass. It's going to pass. Yep. And the rest of these should pass too, because we already did the work. And it's going to ignore other colors because we never ever reference them anyway. So it'll be fine. These should all pass now, which means that this does
What you wanted to do.
exactly what we wanted to do. And yes, look at that, all passing.
But you really cracked this unsolved mystery. I think Ian partnered with our genius bar that we have here in the Twitch stream. You guys really solved this, and truly, I still don't entirely know what it does in a computer other than engage maybe like electrical currents at a certain.
It doesn't do anything like that. It just tells us that that if we pass it the colors green brown, like if I was to pass it, what's on my resistors here? So the first color is red and the second color is blue on this. So if I was to, let's console log that. Decoded value, and then we're going to give it red, blue. Red, comma, that's weird. Blue. If we do that, run the code. Hey, Dev, we're doing better now that we figured out what the problem was, and it's because I was dumb. So I was referencing nothing. I was just creating an array that had the number 0 in it before. That was what was happening. When I do this, I just create the array. I create a brand new array with the number 0 in it. And this is a brand new array with the number 1 in it. And so 26 is what I get back. So that means that this red-blue thing, the value on this is 26. That still isn't quite enough information for me to really understand what this resistor is doing, but I'm getting closer.
Okay.
So that's all this is. It's a little helpful program that if you ran it, it would tell you what this is. And then you could put that into a website, and the website would show you the number 26 when you gave it red-blue.
Unfortunately, that's never going to happen for me. I just don't see that in my future.
There's not that, like, it's a lot of work. It is, undeniably, software development is a lot of work for very little at a time. It takes time to write code, and it takes even more time to write code well. So, we have this thing called decoded value. I hate this name already because decoded value, I'm not sure what that means exactly. It's going to take a duo of colors, right?
Mm-hmm.
And so what we're going to do is we're going to reference each color. The tens digit, we're going to decode it using color code, which we got from our resistor color up here, which, if we look at this, color code black is going to return 0. Color code white, going to return 9. So this gives us half of our job already is done, just because of the fact that this is already working for us. So instead of rewriting that or copying and pasting it into our code below, we just reference it. So when we look at the color code duo, here's our decoded value, and all it is we need a tens digit and a ones digit, right?
Okay.
And how we get the tens digit, or how we get the ones digit is pretty simple. We just ask color code, hey, out of that duo, the last value in that duo, the value number 1, what number is that? And so this right here is going to return 0 through 9, right?
Mm-hmm.
And this one, 0, 10, 20, 30.
This computer understands what etc. means?
So this thing right here is a comment. It's going to ignore this.
Okay, okay.
So if I was to write
that's
that,
for you.
that's for me if I wanted it, yeah. I would hope that I would write code where I don't need comments, where the code itself tells me exactly what it is. But the problem is that these names are confusing me. Color code duo 0, what does that even mean, right? You can't like read that and understand what that is, right?
Correct.
Yeah, so in order to actually do this right, what I need to do is rename these things, and I can. But there's no time right now to do it. People have changed. They're using TypeScript instead of JavaScript. TypeScript is making your code so clean. Yes, it can. Or it can make it a nightmare. And I've worked on nightmare TypeScript code before. It really depends on there's no substitute for having the right mindset around writing code. But yes, you're right. A lot of places are using TypeScript right now. It's a version of JavaScript that has types. Not that that means very much, other than the fact that I can't just pass anything at all into here. Like right now, what's to stop me from putting in true, false, launch the nukes, or anything else into there? Nothing. It'll take whatever it is and try and run it. TypeScript will make it so that it'll throw you errors to tell you, hey, there's something wrong here. That's what TypeScript does.
Got it.
Maybe. I don't understand it. Not that much. Yeah, I see your point about that. Still, writing clean code, you can write clean JavaScript code. You just need to name things well, and this is still not very well named. And that's the reason why we're having trouble.
And that's why we did this show. So that the day you make color duos, you can refer to this episode.
Yeah, we're over time. I really want to refactor this, but I can't. There's just not enough time.
That's unfortunate, because I was hoping we're going to make it to the part where we use that computer to turn on like a margarita machine, or like, I guess it's just a blender. I guess normal people call it a blender, but I call it a margarita machine.
You could use this to do that.
Okay.
Yeah, you could use it for that purpose. But that's going to be a lot more work to get to that.
That's hard to hear.
Also, that's another thing about software development, is it just takes a lot more time than what anyone ever expects. No matter how, every time someone says like, well, how long will that take you? No matter what number I give them, it's going to take longer than that. Even if I try and pad it, it'll take longer than the padded number I give. Oh, just threw my earbuds right out of my ears. I can't hear you right now. There they are.
Well, I just said launch the nukes, so unfortunately they're on their way out. You could have stopped me.
Darn.
Guess you can't.
Oh well. That's at least we got it to passing. We'll need to refactor this to something better later on. I hate these names. That's the problem. The names make it hard to understand, and you would have a lot easier, Melissa, if the names were written better and it would just read like prose. And that's what you hope for with software, because if you're not going to do that, you might as well just take a magnetized needle and just be really, really careful on your hard drive.
Never going to do that.
No,
so I
no
guess
one
we gotta
ever
figure out this code.
Doing that is impossible. I mean, it's not impossible. It's just so unlikely that it would work that there's no point in doing it. So, yeah, naming things well is really what software is about. And keeping your code organized and clean. At least we did get to use the other code for it. I mean, even if it didn't exactly totally 100% make sense. But
it was cool that it got to tie in from something you built with somebody else. All the more reason. Yeah.
Yeah, so that part is cool. Yeah, I know, Erzbane. If we use SSDs, it's even harder. You can't use a magnetized needle on a solid state drive. You have to do something else. McCready13 says, keep your code clean, Melissa. He should be saying that to me. It's my fault. It's my fault that code is gross. You tried your hardest to make it understandable, and I failed to make it understandable.
I think MacReady is reading what he's seeing on the screen, and he's like, if it was her in the driver's seat, it would definitely be a messy code. And so he's visited group text with Erin and MeLissa, so he is probably spot on.
Okay. Yeah.
Yeah.
So
do you think it's MacReady or is it MacReady? I always thought it was like a guy who was like ready. He's has
ready
a Mac.
for Macs. He's Mac ready.
That's what I thought. Oh,
yeah.
Wow. MacReady. Okay. That story's checking out.
That implies that he doesn't actually use a Mac. He's just ready to use a Mac.
That's what I thought. If he was like, if you need a person with a Mac, I got one. I am Mac ready. That's what I assumed. MacReady, send us a message. What is your name?
He says he's a big fan.
Oh, okay.
Which means that with the right resistors, we can control how fast he spins.
Okay, I'm into it. Join us next week when we play plug up one of our guests from the chat, and we light them up, whatever that means.
Oh boy. Melissa, thank you so much for joining me. I was really hoping you could start to see a little bit more clearly you're at least seeing what's involved with coding, right?
Oh yeah, highly. I didn't even know all of this stuff happened. Like truly, this episode should be 6 hours long for you to be like, this is the part of my computer I clicked on to make this window pop open. Because I'm gonna be honest, truly, if somebody asked me to recreate what we did, I would be like, call Ian, is what I'd have to say to
Well,
him.
you don't have to, because here it is. It's right here. And not only is it just right here, but we can always use this for other stuff. Now, the only thing we need to do is name it better. That is a terrible name. So, yeah.
Just know that somebody in the chat is volunteering to also get lit up. So we have 2 volunteers to be lit up. MacReady/McCready and also Nikus?
Nikus? Neikus?
Join us next week when we light both of you up.
Yeah.
Whatever that means. With decoded values.
With decoded values. We're going to decode the values and encode you with electricity.
Yeah.
All right.
Okay.
So, great. Yeah, absolutely. You can, by the way, anybody who's enjoying this, you can subscribe or follow Outpost 13. Also, check out Melissa's show. She has it on Tuesday nights.
Now it's 7:30 p.m. Pacific Standard Time. So come and join us. You might ask questions that, if you start asking me about arrays, where I'm going to send you back to. Oh, sorry, you're on this side.
I'm on this side. Yep, there I am.
There we go. Yeah.
Yeah, nice work.
I'm going to send you right back here to Coding Koans.
Yeah. Got a few other people to thank as well. My production liaison is Matt Pittner. Designer is Aaron Harvey. He has a show called Infinite Trek. It's on Saturdays, where he talks about Star Trek, which is something that I enjoy. Lucas Vanasek is my marketer. He has a show called Two Liars, which is a game show that we do here tomorrow night. I'm not sure if we're doing it this one.
It's very cool. It's very cool.
So the game show, you got 2 teams of 3 people, and there's going to be one statement, and all 3 of those people will claim that the statement is from them, and they'll make up a story about what it is, and you have to decide who is lying and who's telling the truth, which is a lot of fun. Then who else do I need to? Botmaster is Cody Bushy, and he has a show called An Actor Unprepared. It is on Mondays, and that's a lot of fun also. Music that you heard pre-stream and what you're going to hear post-stream is from Made Up Music, which was a show on Outpost 13, which you can still find on Spotify, the music that was made right here on this channel. So check that out. Follow, subscribe, do all the things. There's lots of cool stuff going on here. Melissa, thanks again. I'm going to do an awkward exit that we always do at the end of the show at this point. The sort of awkward exit that happens at the end of any software meeting. Yeah, right, you got it. Just kind of like that. Yeah, okay, cool. So I'm gonna stop the stream now.
Okay, bye, Ian. Bye, everybody.
Bye. Oh wait, I think our mics are still hot. Hold on.
Okay, good to know.
Yeah, they're still hot. Wait, huh? Okay, I think I've got it now. All right, done. No, wait, no, we're not done. I hit the wrong thing.
He only steps up steps too high. I'm just a man. If you see my face at your hour of death, don't shake. Don't shake in your boots, no, don't you fret. Cause I'm gonna take you down where the beats are pumping. Down to hell where the lava's jumping. In the mountain, lava's jumping. Down to hell where the lava's jumping.
Let yourself fall, cause you'll only get higher. Let yourself drop like a beat on fire. Living half dead, so you might as well drop. The f***ers can't find you, the beat don't stop. The beat don't stop. It'll never stop.
I walk this life. He only steps up steps too high. I'm just a man. I walk this life. He only steps up steps too high. I'm just a man. When you start saying a mountain is a mountain, a river is a river. Well, learning Zen, a mountain is not a mountain, a river is not a river. After learning Zen, a mountain is a mountain,